Whew. All right, chemistry people, welcome back. Today we're going to do a little bit of cooking to help us better understand what's going on with stoichiometry. I hope you like brownies, one of my favorite things to make. I have created a simplified brownie recipe, if you will, up here at the top. And essentially what this recipe says is that if you take 3 chicken eggs, 1, 2, 3, and mix it with 1 package of brownies, you can make 1 pan of brownies. And stoichiometry is essentially looking at the relationships that exist between your reactants and your products. Much like when you look at a recipe and try to look at the relationships that exist between your ingredients and your final product that you make. Now, let's say that you're going to have a brownie party and you want to, say, triple the amount of brownies that you are making. You have to look at and determine the relationship that exists between your ingredients and your product in order to determine how much of each of those ingredients you're going to need to make the desired amount of product. And so if I wanted to triple my number of brownies, I would need to triple my number of eggs to 9, triple my number of packages of brownies to 3, and I would make 3 pans of brownies. Again, it's important to note that you're always going to have 3 times the number of chicken eggs as you do package of brownies and pans of brownies, just based on the relationship that we see in the recipe. Now, I want to take a quick moment to remind you that you can apply this same idea not only to individual number of things, but also groups of those things. So, if we were to say want to make a dozen pans of brownies, the relationship will still hold true here that exists between the ingredients and our product in our recipe. We would need not 3 chicken eggs, but 3 dozen chicken eggs and 1 dozen pans of brownies. And again, that's going to come into play here when we start talking about how you can read a chemical equation in terms of individual molecules and atoms versus numbers of moles. All right, chemistry people, today we are going to relate quantities, measured mass of substances, volumes of solutions, or volumes and pressures of gases to identify stoichiometric relationships for a reaction. Stoichiometry, get ready. Basically, as we break this down, we're going to do a lot of stoichiometry today. We're going to do some stoichiometric calculations that involve amounts in moles and masses in grams, sort of the standard run-of-your-mill stoichiometry. Then we're going to do some stoichiometric calculations involve volumes of gases, both at standard, so using that 22.4 liters at STP relationship, and non-standard conditions where we may have to use some PivNert. And then lastly, some solution stoichiometric calculations involving concentrations with molarity. So lots of stoichiometry, lots of math today. All right, so first things first, again, as we look at our chemical equations, those chemical formulas in those chemical equations are going to share with us the ratio of different atoms in any given molecule or compound. For example, H2O shows 2 atoms of hydrogen are combined with 1 atom of oxygen in each molecule of water. Those chemical formulas can be converted to masses by using atomic mass data from the periodic table, which we took a look at in some earlier videos. And then as we discussed earlier, it's those balanced chemical equations that bring those chemical formulas together to show us how they change in chemical reactions. And then really it's the meat and potatoes for today's lesson. It's to recognize that those formulas have stoichiometric coefficients that show the relative numbers of particles and moles that react in those chemical equations. So ultimately, stoichiometry involves the study of the relationships between the reactants and the products. The concept of stoichiometry is very similar to the doubling of a recipe while you're baking. All right, now as we try to apply that idea of making brownies to a chemical example here, we're going to start with a really basic chemical equation, and I've got some sort of visual representations here of the different ingredients in our chemical reaction. So as you take a look, I'm just going to start by describing the chemical reaction in sort of a more visual format. So we've got 2 moles of hydrogen, 1 mole of oxygen, to make 2 moles of water. And just like the example with the brownies, it's about looking at the stoichiometric relationship described by the coefficients in the balanced chemical equation to understand the relationship between the different things in this reaction. So let's say then I wanted to double my recipe to make 4 moles of water. In order for me to double my recipe here, I would then need 2 moles of oxygen and 4 moles of hydrogen. Again, the idea is to look at the coefficients as they exist in the balanced chemical equation to help determine what the relationship is between those different reactants and products. Ultimately, your study of stoichiometry can be summed up in this one graphic. Once again, the moles are the boss. They are the place that you need to go to first. You've got to run everything through moles before you can move on. So I encourage you to take just a few moments and become familiar with the relationships that exist between moles and those different quantities. And again, it's important that you go to moles because in the balanced chemical equations, those coefficients represent the ratios in moles. So keep that in mind as you're working through these problems and study this graphic.